Hello, guys. Hello. Hello. Hello, guys.
English.
How are you doing?
Good
Good to see you.
Yeah. Doing well.
Okay, so let me adjust my microphone and we'll get started. Okay, I think we are ready. Let's see, people are still joining in. You should be able to see two cameras from me, I guess. No, the second one starts, and you already see both cameras and also be able to see my desktop, I guess. Yes, and I am looking at who is here. So we got 8 people by now. Others are still trickling in, but we should just start in just a few. So I am opening up. Okay, more people are trickling in as I speak, and I get alerts. I don't think you hear those alerts when people come in. Maybe you do, but I do get messages telling me that people have showed up or people are disconnected, reconnected. How is the audio and video quality? How the frame rate is? How is the expression of interest? You have thumbs up, thumbs down. I see all of those things, which you probably do not see, but maybe you do. Well, having said that, I want to begin reviewing quickly what we did the last time and extending those ideas this time a little bit in a deeper direction that helps users improve performance. That's one of the primary goals of this storage technology, essentially, is to help people, end users, people, with a better set of performance characteristics. So that's one of the reasons why these technologies, right, like we discussed, using a bucket and putting an item in the bucket, it not only helps disassociate from the core set of computers that you might have in a application. Like, you don't want to store all the data in these boxes, but instead you want to keep it outside, right? That's the discussion we had the other day. And so for that, we will use a bucket. So we'll put our item that we have, like this item, whatever that item is, we'll take this item, and instead of putting it here, we don't want to put it in these machines, but instead we want to put that item in a centralized service, external service, which is different from our boxes. So these boxes will store our application, but the user generated data, the user send, sometimes we create data, sometimes applications themselves will generate data. So that data that needs to be along with the application needs to be ideally stored externally. And these data can be, pictures, videos, music files, PDF files, whatever you think of storing along with your application needs to be ideally going away, stay somewhere else. That's the scenario. which is, we are attempted to implement in form of a bucket. And we played with it, like putting an index HTML file in there. And we saw that, we are able to access that file if you edit the permissions for everybody to be able to read. So read by all, everyone, you can see this file in a web browser. We then extended the idea by using a static site generator. A static site generator example that we used was a tool called Octopress. Octopress is a Ruby-based tool. And we used this tool to generate a static site, and we uploaded all that content into a bucket, a new bucket this time. And that Ruby tool we got, this Octopress, it requires certain dependencies, right? So dependencies that were required dependencies, we installed them by running a command called bundle, if you remember. So this bundle install step basically gets all the dependencies for this application and loads them up, makes it ready. Now we can use the Octopress tool. Then we basically ran some rake commands. Rake do this, rake do that, rake basically create blog post. So create a variety of blog posts that we did. And then we ran rake generate. This generation step generated HTML, CSS. We also edited these posts that we create, right? A couple of them, we basically did not much editing. We just barely touched the idea of modifying because we were focusing not so much. Oh, somebody is saying, are we late? That means she's not able to join in. Hold on. Somebody's just pinged me. Are we running late? We are already running. We are already online. And let me give her a link so she can join in. So inviting her. Let's see if she's here already. No, she's not online. Okay. So let's invite her. Where is the invitation button? Okay, let's see if I can invite her. Invite, copy the invitation, and in Slack chat, here we go. And so I invited her again. I think she'll come online. And sharing screen now, one more time. And then go into that workstation, which I'm going to start up and remind everybody that we created this set of HTML, CSS that came and showed up in a public folder, right? Maybe not that location, but a public folder was created. And then we synchronized the content of this folder with that bucket, that a new bucket we created, right? So anytime we want to make a change now, what we can do is basically go back, create new post, and edit them, generate new HTML, CSS, JavaScript. This new generation step is needed. And then we synchronize whatever we generated with the bucket. And as soon as we do that, the new website goes live. The site goes live with new content. You can see these things happening very, very easily by going to that location and identifying that we were working on a folder called Octopress. Here, Octopress. And in that folder, we had a bunch of things. We'll open it up, what it contained. So it reminds us as to what it had. We saw that this public folder is where the content got generated. And these three posts that are here that says, hello, Chris, and then hello, Brian, and hello, David. These three lines were added as an edit effort, as a part of editing. Now, this was very trivial in terms of an example to show editing. And, basically what we saw was a result of a website that kind of sort of looks like a decent website, but again, it did not have enough meat in terms of content. So how do you edit content? That's a quick side topic that I want to just highlight. And we can, of course, put these things to use. If you go here, for example, in a browser and try to look up a word called Markdown. That's the technology that is used, Markdown. This technology which is created by this person. His name is, I think his name is, it'll come up, John Gruber. So he's an Apple fanboy. He created a technology to write complex HTML formatted documents in plain text. And this has been picked up quite a bit by across the board by most technology companies. For example, GitHub. You look at this GitHub app, as a place, and we'll see some famous repositories. Like, for example, this Kubernetes. The entire documentation and this README file that you see here, this picture, the introduction, and the labeling and code of conduct, all of that is written in Markdown. You can see that by looking at this README file, readme.md. So click on it. You see that this is the README file that we saw, and we can look at the raw file representation, the raw representation. Click, and you get the raw. So if you take all this raw, copy it, go back to the virtual machine, which is here, and then instead of David Thiemens, I'll just remove that, delete, and put my paste that I have from the Kubernetes GitHub README MD. This is what we copied. So this is a representation of whatever Markdown representation is provided in that example that we just showed, which was basically this website, right? This is the Markdown raw format, and this is how it looks in practice. So we now are able to get some edits into our site very easily by cutting, pasting Markdown sample content. I'm just putting this as a sample to illustrate a point, is that we can very craftily create good looking content, nicely formatted content with plain text like capabilities, which is this thing called Markdown, which is very extensively used by almost every technology company to write documentation, to write code snippets. And also, if you look at the Cloud Genius website here, and you look at any of the exercise materials or reference materials that we have here in this segment, in the My Account segment, wherever you go, like for example, the Cloud Technologies exercise is in module number here, 11 or 3, whatever that module is. This segment that you're looking at is also Markdown. All of this writing is all in Markdown, and I will show it to you in just a minute. By clicking the Edit Unit button, you can see the source code behind this video, and the cider notation references, and all of this is written in Markdown. So we'll take this as a second example, copy it in its entirety, like copy, take it to that workstation, put it in the second Hello Chris reference. I'll remove the name of Hello Chris, cut it, and paste instead with the content we got from our Cloud Genius website. And I'm going to save this content, close out this window, and now go back here and say rake generate. And when I do this generation step, it generates fresh HTML, CSS, JavaScript content. Now we have new content developed and ready. So I want to see the content live in a local machine. I can rake preview, and I can see that this generated content, HTML, CSS, JavaScript, is now running locally in a local web server running at port number 4000. So I'll open up my local browser and then visit localhost at port 4000 to see the new changes that I have modified, and I'm able to see that right here in localhost port number 4000, like that. And it should show up whatever I did. So the Kubernetes content showed up on my third post. You can scroll through it, see it, check it out. It looks decent because it's a copy and paste of Markdown, as you saw. And you will also see the first post, which is this one, actually did not correctly copy the video files. The expected embeds that I'm expecting to see here should show as video embeds, because the way I use Markdown in the Cloud Genius site is slightly different than how Octopress uses video embeds in Markdown. So subtle changes, subtle differences. You have to account for that as to how Markdown handles. And now you have a reasonable representation. Again, this did not come out very clean as I expect. This is very clean in the representation in formatting on the site here. If you go back, it looks clean. The two videos show up. The table is drawn properly, whereas the representation we just saw here is slightly muddy. It's not clean. And the video did not come through across as expected. We expected proper video player. It did not show. It should show if you use the correct supported markdown methods that Octopress requires. So essentially what markdown does, and by the way, now at this stage, now that we have a public folder created, we are able to see it locally. All that needs to be done is do another sync. And if you do another sync, it goes to the site very, very easily, very, very quickly. Many companies that are in the publications business actually create static sites just like this. And they use these generation tools like we are using Octopress. By the way, there are many such beautiful variety of generation tools that will generate good looking static site. This is static, meaning there is no database. And let's go quickly do a survey as to static site generator. How many of those are there? So there are lots and lots of them will pop up. One of them is this Hugo. Hugo is a Go language based generator. We have more Jekyll, Middleman, Robots, Hugo, a huge list you can see in this page probably. Large number of generator tools, and each one of them conceptually is kind of similar, but they vary in the language they use, the styling they use, and all of them are static, meaning there is no database, but they are very easy to use. You just install it, modify it, and you have a quick, nice, decent looking site ready with you. And you can modify the look and feel also, like I'll go to Octopress and then ask for themes, and you will be able to find a variety of themes here, third-party themes for Octopress. There are a bunch of them available. Lots of people have created all of these things. All of these line items are essentially variety of different themes of Octopress. So let's take a quick look at one of those guys. Like Typo is the name of a theme. So click on it. How it looks is like this. So the Typo theme looks like this. So it's a styling issue, right? So how the CSS HTML generated looks different than what we saw here. This is the default style, this one. And so the idea that we should extend now what we just did is back here in the notepad is we saw the workflow. Once the setup is all done, the workflow is fairly simple. You come here and create post, you edit post, and then once you edit it, you check it out locally by generating content, generating the public content. So whatever you have, HTML, CSS, JavaScript gets generated, and then you synchronize with your bucket. And then you go live. That's all it takes. You can repeat these steps over and over and over again and keep your site up to date, up to how you like it to be. It's fairly easy, no other maintenance needed, and no other maintenance of the server needed, because there is no server. I mean, there is actually a server, but you don't have to manage it. There is a server, by the way, that Amazon runs for this bucket as a service. They are giving you a bucket, they are giving you a place to store, but they are in the back end converting into a site and running a service and all that, but you don't have to worry about it. The beauty is you don't have to do anything, just use serverless storage to create static sites. The beauty of these things is that it also runs a bit of JavaScript in your web browser. And so when you're looking at, say, for example, this website, there is an element of JavaScript included in your browser. So you can then use that segment of JavaScript to interface with a backend that you then create and manage. And that can be extended to create a dynamic site. So what this was, it was a static site. And you can extend this with the use of JavaScript on the front end to make it a dynamic site by providing additional backends. So you have to provide some kind of an additional backend database and some other method to support, and you can then have a dynamic site. which is what you traditionally see most of the times. Most of the times that has a database involved is typically a dynamic website, like most sites that you see, including, where is that? Including this one. This is a dynamic site. It has a database on the back end. And most sites that you may or may have seen actually are dynamic sites, but some of them are static, and they can get away with accomplishing a specific goal that you might have for publication of content. If the publication flow is like a couple of you plus team, and these are the people who write, and a whole host of people that read. If that's the model, millions and millions of readers, maybe static sites are relevant, and they're probably more appropriate for news consumption, blog post consumption, or other kind of publication. If you're a small team writes the documents and then everybody else is reading it, that scenario is very well suited to writing static sites. Now, having discussed this, let us extend the idea in terms of how do we now make sure that we are able to improve the performance for our reader. So if you have a reader, let's say, who is sitting somewhere in Nigeria, for example. I'm just picking up Nigeria for no reason. And so there is a reader in Nigeria who has an iPhone, and he is or she is opens Safari browser in there, and your poor bucket here is in your Seattle. And so that traffic that originates, a request comes in from here to go access the bucket, and then the response will go back to the browser. That can be kind of slow because of distance. Even though it is all speed of electronics, and so it's reasonably fast. It is not speed of light though, but still can be perceived as a little bit slow. Imagine a situation when they had a machine directly, say, in a European location. If you have a machine set dedicated that replicates this in Europe, it is probably faster for the person in Nigeria to read from a European server compared to reading from a Seattle server, just by the fact that it is closer in geographical proximity. The distance is small between Europe and Nigeria, comparatively speaking. And so if that's the scenario you can put together, you might be able to provide a situation for your global audience to reduce the access time, to speed up delivery of content, to make their experience a little bit better. That's the core idea behind the idea that I'm talking about next. And that is content delivery network. Now, if you go search this key phrase in a browser, CDN, you will find hundreds and hundreds of example companies. Oh, not this, Google, and then CDN. You will find hundreds of examples. And one of the ones that I will talk about is going to be called CloudFront. That's the example I will discuss, and CloudFront is a service from Amazon. That's the one we'll discuss to begin with, and we'll discuss others also. But this service, how many of you have actually used this kind of content delivery network services already? I just wanted to get a quick idea about who's up to speed on this and who's new. So if you have used it, just say a chat in chat, or just speak up. That's also okay. And so what I'm going to discuss this thing now is the idea, which is the idea that is already described in a picture that I have created a while ago for you. And that is, I'm going to go to that site. And it is right here. If CDN is not new, just say, yeah, I've used it before. That's what I was expecting. So I will go and show you a picture that I have created, and that is this. That picture is coming up. Picture should pop up here. It did not. Well, I'll draw it. The idea is that if you let's see, not new, no, okay, new for everybody apparently. So so the idea is, let's go in a fashion to simplify. So in very simple terms, what CDN does is, if you have something in the middle, and you want to go far places, The idea would be to create replicas. Replica worldwide. That's the core idea. And so take your central content globally, far, far away in multiple places. So if you go now look at this example of the service that we are talking about from Amazon CloudFront, the key value proposition this thing does is, if you go log in, which I will log in and type in a token, and in the token, it's already logged in. If you go look at CloudFront, which is this, the core idea here is it already takes your content. I think I logged into a wrong account. Sign in again and sign into the console and sign into the correct account. This one, not the other account. And then grab the token. And then we'll see this particular service as an example, and that is CloudFront. And the core idea implemented in a quick example is right here. So I will discuss this now. So if you now look at the example, which is going to be this endpoint, I will grab that endpoint as an example I want to discuss. I'll open up a terminal, make it full screen, make it big, and dig. What I would like to do is dig, and then check this out. Who are you? I want to find out who are you. So it says I am 8 different endpoints. The question section was, give me the A record, the address record for you, whatever this thing is. And I got 8 answers, 1, 2, 3, 4, 8. These are 8 endpoints worldwide distributed. Now let's go look at on the website in CloudFront. What is the origin, the beginning point? The beginning point for this particular item is actually an Amazon bucket. If you go look at the origin segment, the origin comes from this location. Now let's go see what that thing is. I'm going to go copy it, edit to make it clear. The origin name comes from this endpoint. Now what is that endpoint? Let's go see. If you go to a browser and open that endpoint, you should see the same thing that we have been discussing all along, right? Now let us go compare it with Atom Editor and write these things down side by side to clearly understand where these things are coming from and how do we make sense out of it. So here is a new sheet of paper, and here is one link. The other link I was playing with was this link. So I'll copy that, put it on the side like that. And the A record result for this line number 7 turns out to be, and I'll grab all these records. And so I'm copying them here and then bringing them temporarily, placing it here. So you see that line number 7 represents 8 different A record endpoints, 8 different IP addresses globally distributed. That was created from the origin, which is referred in line number 5. Now, what is line number 5? Where does it come from? It looks like a bucket to me because I can tell it is an S3 website in the US East 1 region. So I can tell it's a bucket by this name, blog.cloud, blog.whatever. Yeah, so that's the bucket name. Looks like a bucket. Let's go verify that. So back here in our bucket technology, which is going to be back to the S3 segment here. And let's go see if we have a bucket here called blog.fungibleclouds.com, and apparently I do, and that's the bucket. Click. Now if I go see the properties of this particular bucket and see if there is a static website hosting provisioned, click, and I find that it is giving me an endpoint because I have configured this as a static web hosting, and the link happens to be the link I have from here. So I right click that, copy it, and then go back to our notepad, compare it, and it is the same thing. Sorry, did not paste properly, did not copy properly actually. I should copy the whole thing, and then put it in line number 3. And if you remove the HTTP, you'll see that it is exactly the matching with number 5. So line 3 is the bucket called, bucket was called this. That's the name of the bucket in line number 1. We converted that bucket into a static site that gave us an endpoint for the bucket in line number 3. Then what we did is use line number 3 as the origin point, as the middle point, center point, and asked another service, CloudFront to go take this bucket globally, like worldwide. So in this example, it has taken it to 8 different endpoints. And those are from 7 through 14. That's the idea behind that I'm describing in the picture now. So I'm going to change over to a notepad here. And so in the middle, we had a bucket. We converted that bucket into a static site, and then using that as the origin. And we said, CloudFront, take this origin, please, and create 1, 2, 3, 4, 5, 6, 7, and 8 replicas for me. So it did. Now these replicas become globally visible, globally available. They all go by the same name. The name is 5, number 5. That thing, that name is what I have assigned it. I mean, it got assigned that random name. It is very difficult for me to remember what that thing is. So what do I do now? I said, you know what? Let's go do something called CNAME now to make it simplified. How do I simplify? I put a CNAME, blog.fungible.clouds.com is a CNAME for this ugly thing, number 5. So I will do that entry in my DNS. So this you are a CNAME for this ugliness. That's the CNAME I put. And then suddenly DNS knows whenever I type blog.fungibleclouds.com, it should automatically try to go to this D2H, whatever that thing is. And the fact that it is a 8 endpoint record provided to us by CloudFront, it will resolve to the nearest one, the nearest IP address through proximity. And it will automatically try to access from that location. Now that location actually needs to originate from the origin, which is line number 3. And so the origin will get request to read from line number 3 to begin with. And line 3 is the web representation of the bucket by the name given in line number 1. So at the end, if you have a user who happens to be this user who happens to visit line number 17, that is a CNAME record, he or she will be transferred automatically to that ugly name, and which is a multi-endpoint situation distributed worldwide. And that's where the content will be rendered from. However, it is a distribution. It's a CloudFront distribution. It's a content delivery network distribution. And so what in turn will happen is goes back to the origin, to number 3, and then pulls from the origin whatever is missing. So I just used a new word called missing, which is very likely the case. When the first time a new block comes up and the user tries to access line number 17, and he or she is not able to find anything because the CloudFront is empty to begin with. Nothing is there globally except in your origin. Your origin typically has whatever you want to send. And so it has the stuff, like whatever you have in your bucket will be in the origin to begin with. But the user comes along in Nigeria or in Thailand or China, somewhere. But you are in Seattle, your origin is in Seattle. Actually, this particular origin is in US East 1. So it will be in, hold on. This origin is in US East 1, so it will be in Northern Virginia. So you have your item in Northern Virginia, and your geographical distributed endpoints are global, but they are all empty. The user comes and says, hey, show me something. And it is a miss because there is nothing to show. So the user gets a miss. So when it's a miss, it is as bad as if there is no content delivery distribution at all. As performance is as bad as if there is no CDN. The miss basically leads to the user go all the way to US East 1 here, origin. It needs to go to the origin to grab the content which is missing. That was a miss. But next time, in that geographic proximity of this user, so say this is Nigeria, and so Nigerian user gets a miss. And now the next person in, the neighboring Niger, this user he or she will have a hit. A hit as in it is available from the European endpoint. They don't have to go all the way to Northern Virginia to the origin. The second user from Africa, from Niger, will get a hit. The first user will have a miss. So this hit and miss scenario is basically the idea behind caching. Caching is that these endpoints that you're looking at in these lines number 6 through 13 are different globally distributed cache that stores stuff from the origin closer to the user. That's the core idea. Closer to the user. So you have these users in Nigeria area, and this user in Thailand. This is Thailand, for example. This guy was in Africa, and so the replica here got a miss to begin with. Then this user was forced to go travel all the way to the origin point, and then when it came back, it will actually populate the replica, and next time the next user from this region will have a hit. And that's how the second user and the subsequent user's performance will be improved a little bit, tiny little bit. But all these tiny bits globally are actually relevant to the end user. And if you have traveled across in another country and you try to access your corporate computer from another country, you may have noticed the slowness, the sluggishness that you may have seen if you try to access your laptop through a virtual private connection back to your company headquarters. You probably have seen when you travel abroad. You may or may not have seen, but that happens. It becomes slow. And that is because your traffic is actually going all the way from your traveling location, destination, back to the corporate headquarters. That becomes a contribution to the amount of time the traffic has to flow. As a result, performance goes bad somewhat. And when it is our customers who are paying us money for a variety of services that we offer, we don't want to give them bad experience. So this kind of a delivery model of content delivery network helps a whole lot. Let us take a look at it from a different perspective now. So there's a chat request. And so the question is, so does the first user in a given region that is too far away from the origin always a miss on the first attempt? Correct. Yes, it has to be a miss to begin with, because nobody has no idea as to what it has. And so the first one in every region will be a miss. And then you will immediately see that the second user will be a hit. And you can see these things in the CDN itself. You can see how it is a hit or miss. So we'll go to CloudFront and see what are the hit rates and miss rates and all those statistics. They will accumulate for us and show it to us as soon as we are able to go and see an example. Like this one, for example, that's what we are dealing with, this site. So we'll click on that one and see what are the cache statistics. So we'll go click. And this has collected statistics for for quite a large number of times. I think it's a very old site that I have not been updating. So I'll just go to 2002, 2012. Maybe AI it's kind of not able to type here. What 201? No, they don't let me type. How crazy! But let me type the date. No, but whatever. So let's update and find out the statistics of cache. Here, there were lots of requests in April 11th for some reason, but then these are total number of requests. As you can see in the graph, total requests. You can see that it is showing you hit and miss ratio and some errors. There are apparently at least some errors showing up for some reason. There are hits and misses. You'll see most of the items are in green colored, like hits are green, blue are misses, and then red are errors. I did not bother to find out what the error is, because this is an academic example. This whole website itself is an academic example. And it by the way, it doesn't cost me too much to run it like this for last so many years. Since 2012 is the date of publication for this. I have been running it and paying like 2 cents a month, something like ridiculously low, because it doesn't really cost me a thing. It does, I mean, thing as in 2 cents. Yes, that is thing. But then otherwise it is not expensive. The bucket is cheap. The creation of a static site on top of an existing bucket is free. Using content delivery network can become really expensive. However, nobody visits this website apart from you guys. And so there is no cost. If there is a lot of access to this site, then the CloudFront cost can accumulate. CloudFront costing, the pricing is actually based on number of gigabytes downloaded by the regional endpoints. Pricing of buckets is also structurally similar, is number of data stored, how much data did you store, and how much did you access out. The inbound access is free, the outbound access, they charge for it. I think the bandwidth is charged for. But apart from pricing discussions, this technology is tremendously useful. It basically helps you improve performance of a, let's see if we can download that image, or see the image. Okay, file not found. That's the reason why that picture is missing. But I will come up with another picture for that. The picture basically, and there's a question again. So follow-up question, do the distributed endpoints only get created by the content delivery network once there is a miss near that region? The answer is no. They already exist. These endpoints already exist according to a service provider. They just are there. They're not dynamically generated. They are not serving only you, but they're serving a bunch of other customers. You just happen to be a tiny little part of that endpoint. And so they don't create one, they just exist. Now the next part is, or do the endpoints get created when you sign up with CDN? No, they already exist even before you sign up. And then the cache data only gets replicated once the miss happens. Yes, the last part is true. Cache data gets replicated when somebody tries to access and they don't find it. So then they go to the origin and grab it. Now let's go see where CloudFront endpoints are. So we'll go this example, CloudFront endpoints. Where are they? And so they'll tell you what's an edge location. So everybody will have a different name for the location. So here they call it, at Amazon they call it edge location, whatever. That's the terminology they use. So let's see what are the edge locations in Amazon. So we'll go read details for that. And they have, okay, here are the regions already defined. The CloudFront Global Edge Network. In Northern America, Europe, Asia, South America, they already have regional edges in Mumbai, Australia, regional cache in Frankfurt, England, and other edge locations. So they have presence. I mean, big companies have global presence like this, like you saw. But one thing that was missing is Nigeria, for example. That's the reason why I chose it. They don't seem to have African locations, unfortunately. They have everywhere else, it seems, but not Africa. Okay, that's what it is. I mean, I cannot fix it for you, but you just have to go travel to Europe, the nearest location. And so that's how users will go, probably to, say, Madrid location or some other close by location, which could be closest to the Nigeria region. Or yeah, look more like from a electronic ping perspective. That's how you should measure. For example, what I'm saying, distance is not really relevant factor. The relevant factor is a ping stat. So for example, the endpoint that I'm pinging right now, between me and that endpoint, I'm collecting ping stats, and I'm going to break it now. But here are the averages. You see that on an average, the ping number was 13.133. That's the number you got. So that's how the idea is to be able to ping all the points available, find the closest one that gives you rapid performance, and select that one. And so let's go back in summary here. At the very top, you have the bucket. Number 2 is the site representation of the bucket. Number 4 is the service endpoint from a content delivery network. You in turn receive, in this example, only 8 endpoints. And then you have to go assign a friendly name to it so that it becomes easy for people to digest and remember. And then that's the friendly name I chose in line 16. And then you see hits and misses, and that's the concept. Now, what you could do, there's another question. So question is, suppose a user accesses a website from a location halfway between 2 endpoints. How does the CDN decide which endpoints to use? So if CDN doesn't, it's the browser of the user that decides which is the nearest. So the browser gets to select. The browser will decide which is the faster resolving A record out of these. So they have 8 answers. They will select the closest one. The first one to respond is usually the good one. They just start taking it. And that's how resolutions will work typically. If they don't get a response even from the closest one, they try the other one. So geographical proximity is not really the right way to say it. It is ping times and the access times, the actual electronic proximity. I just made up a new word. Electronic proximity in terms of the route between that user and the nearest endpoint. Whichever is the closest one in terms of electronics, that's the one will get picked. It need not be geographic proximity, because sometimes you have faster, low latency networks between two big continents like Europe and US. A very low latency between US and Europe, but reasonably large latency sometimes between other parts of say South Korea and US. There are these high-speed networks like CME, you may have heard of. That is a intercontinental network that runs a pipe like this globally. This is the CME pipe. And like that, there are many other networks globally spread out. These are underwater cables that carry internet traffic. This is just one example. So many such things exist on the internet, on the public network that carries traffic. That's just one example, but there are many such networks globally under the sea that operate, and there are examples and videos of sharks trying to eat the cable and internet outages happening. You may have seen those in YouTube. It might happen. Internet goes down because a shark ate the internet. So search for this and you will have some fun. Okay, next. The way you use this is just one piece of the puzzle. If you really want to improve performance for the end user, there are lots of other things that need to happen. This is just, of course, a big help. CDN is a big help, but it doesn't fully solve the problem. And let's go understand what does it take to fully solve the problem. By the way, as an exercise, what you should do is convert your static site that you have just in a bucket and convert it into a static. Put a layer of content delivery network on top. It's very easy. What you need to do essentially is, you have your central bucket. You convert that into a website. That is your origin. And you go to some CDN, for example, CloudFront, and you say, what? Origin. What is your origin? This is my origin. So go create a CloudFront. It's just like a matter of 2 or 3 clicks to create a CDN. Put that CDN layer around your origin and try accessing it from the CDN point of view and see how it works. That will give you a first-hand experience of using content delivery networks. It's a very easy example to play on your own. If you need help, chat with me. We will put a CDN wrapper around your origin. And that is actually a fairly simple exercise. I don't even need don't even see the need to demonstrate it. I just showed you an elaborate example that is already here. So you can follow these things and follow the example of this name and create a CloudFront distribution yourself for your own bucket and play with it. Another chat. So suppose a user accesses a website from a location halfway between 2 endpoints. So how does the CDN decide? I think I answered that. Does the bucket provider and the CDN provider have to be the same company? No. Exactly. Good point. And so the next point I was going to discuss was this origin doesn't even need to be a bucket. Not at all. It has nothing to do with the fact that we use a bucket. You can use custom origin. Custom, a machine in my garage, custom origin. That is also possible. So you put a machine in my garage as a custom origin and put a content delivery network layer around it, CDN. And now I can go to my garage, make an update, and I can reach the global audience at a decent performance because of a CDN. My CDN will go back to my garage, go to the custom origin. This is the server in my garage, for example. server in my garage. And so it will go, as long as the garage is accessible on the internet as a public IP address, CDNs can come to the custom origin and replicate its content globally for cheap. As long as you're not going to be showcasing your website in the Oprah show. If you go on Oprah, your server will probably die because you probably don't have enough bandwidth to sustain. And also you will get a huge amount of bill from the CDN providers if you happen to be showing up something on Oprah, and lots of people, millions of people will access your site. It will not go down, but you will absolutely accumulate a lot of bill because of CDN access. Just telling you that it might cause you a bill. So if you are going to Oprah, prepare something interesting that people will actually monetize for you, so you can compensate yourself for the CDN cost and make good money. So if you, before going to Oprah, have something to talk about, have something to show and sell and tell. Okay, next, custom origins. That answers the question being asked. You can choose a origin from Google Cloud and put a CloudFront Amazon CDN around it. Totally okay, doesn't hurt, because it is designed to be geographically separate. It has really no impact on the end user, not too much impact on the end user performance, because the CDN takes care of serving the end user, not the machine in your garage or not the machine in the other cloud. In fact, you will see an example coming up pretty soon where I use a machine in the Vultr cloud, which happens to be this machine. This currently, I have deliberately disabled CDN on this site to show you an example. How do you add a CDN to the site? And I will walk you through examples like that. So you will get a live example, a live feel. Right now, the site may be a little bit slow for you because I removed CDN to show you an example of how do you add CDN to a live website. We'll do that. Not right now. One more thing before we jump to that. So in essence, when you have a server in your garage or a machine in your another cloud or something else that needs to be visible to a global audience, and you want to go big, go wide and public and worldwide, you need to worry about at least two different types of content. Two types. These types are basically some files, mostly HTML, CSS, JavaScript, those kind of files. And the second thing you have to worry about is data in the database. Some data has to be there. For example, if you go and log out, that is, now we go to log in. So there is this data that flows, username, password. That data needs to be transmitted. It needs to be stored in the backend in form of a credential data store of some sorts that requires a database. So that database is separate from the files that are stored on this website. So I can log in here very easily with another way, and I can get into the back end of the site and all that good stuff. But the transaction that is happening is actually between a database on the back side and the browser in this machine. That's the transaction happening between some kind of a database on the back. Let's see, here's the database you have. And here is some server running. That server is actually rendering you what you see. So whatever you see here is what is rendered by the server. And it in turns accesses a database, which in my example that I just showed you was a MySQL database. And this server can be a bunch of things. We'll talk more about how the thing is, but I'm just simplifying it to be a server. And it interacts with the database server separately. And essentially what you see is a collection of files rendered to you in your browser. So that's where you see the result. The browser has a browser cache. Let's see. The browser has, hold on. Yeah. So browser itself has a thing called browser cache. You may have seen this, browser cache. And that cache we should exploit to the best possible extent we can, so that the user is happy and satisfied and feels good performance from your services that you are trying to show. If every time, every single thing goes from this server all the way to every single browser on a planet Earth, that is actually going to be lame, because you don't want to be sending a file every single time a user is like clicking, boom, clicking here, clicking there. And it becomes a nightmare on your server if you are trying to service every single request from a global usage, a number of users you might have globally worldwide in variety of browsers. It becomes a nightmare on your server. So what do? You put a CDN in between. I mean, that's great. But then the CDN has to still serve, and there is still a method of optimization you can put together by using, or rather, I should use the word leveraging, the browser cache. This idea of leveraging browser cache basically comes down to the fact that you speed up here between. So this is the user's iPhone, for example. This is the user's iPhone. It has Safari browser, and in that browser there is a browser cache. So we need to exploit that cache to the best extent we can. For example, if the user goes and opens this site and this Murugan's picture pops up, I need to make sure that this guy's picture that I have here, save image as, and I can save it to download. So, I just download it mechanically. But the idea is that there is a cache in the browser that should automatically save it. So this Murugan guy, he is one of the graduates here from Cloud Genius. So let's go see. The idea is, just like I've saved locally the picture of Murugan. I think I lost where the picture is, but somewhere in that folder should be Murugan. There is Murugan. So this picture I just showed up locally downloaded. The browser also saves it locally in the browser cache. It does by default. And it relies on the properties of that particular item that is coming from the origin to read how long should that browser should keep that picture of Murugan in the cache. And then what should be the age of expiration, for after how many hours, how many days, how many years you can set that this picture will become stale and you should discard it at certain amount of time. It is called cache expiration. A certain item, every single item in your site that is coming to the browser should be set to expire appropriately. Like for really fast moving, dynamic changing objects, you should set expirations low. For a picture like this, it is probably 1 year. I will never change the picture because Murugan is Murugan, he's not changing. There's no need to change his picture. So I will set expiration for images like this to be long period of time, like 1 year. And when I do that, what is going to happen is this browser will store Murugan's picture right here in the cache, right there in browser's cache. So muru.jpg, that file will be sitting right here after the second and third and fourth and subsequent logins. If the browser is attempting to access Muru from the server, it knows it has it locally and the expiration is set to 365 days. It is not going to go even to the CDN. It knows if the cache copy is good enough and it will just use it. So that is how you introduce and make use of the browser caching to expedite performance of the end users by exploiting the capabilities of the user's device. Every single browser in every single computer, phone, device, whatever you have, has a cache. You can see it. You may have heard of this thing called cache. Let me show you. Cache, empty cache. So I can empty the cache, click, and all the cache I just destroyed. You can also disable caching on browser, but don't attempt that. This is a developer feature. As you can see, I'm on the develop tab, but I'm just showing you that the idea of disabling caches is to just disable that feature of caching at all from the browser side. So that was the browser caching aspect, which is, you don't even reach the CDN. You are just exploiting the local device capability on the laptop, on the phone, on the tablet, whatever you have. Right there is cache. Use it to the best extent you can by setting expirations to the items that are stored there that do not seem to change. For example, pictures, they don't change too much. Next layer is this content delivery network. This item you already discussed briefly, which also helps expedite performance for the end user a little bit by bringing the origin content closer to the user, geographically closer. And now we'll go back one more step, and there are further optimizations you can do at the origin itself. And that is what I will briefly talk about that a little bit. And these are some of the concepts that I'm describing are mostly, again, about caching. That's the whole concept. I'm describing that. So let me illustrate that point in a different fashion. Here you have a database, and that is very likely to be the case on the back end of any service, that you have a data store which is going to store in some database like MySQL, for example, Microsoft SQL, Oracle. Bring your database, I don't care. Some place to store some data. And that is where the data is stored about user credentials, any other content that is in a tabular format, that is a structured format. You can store that in a structured database, also known as a relational database system. Store that in that database. And this thing needs to run in a separate server that will be called the database server. It can also be a separate service, which will then not require a server, but then you will be using a service known as the relational database service. For example, Amazon provides you a service like that. Next, what you need to be able to do is find a way to avoid querying this service or this database itself. To the extent you can, just avoid talking to the database when you don't have to, don't need to. When things do not change, this server that is serving your content need not bother the database at all if it doesn't need to. And that requires another caching at the server side. That caching can be seen in form of a variety of implementations. An example of that is called Memcache. This Memcache D, to be specific, is the name of an open source product that is available that you can run. And what this thing runs is a separate server. It is high on memory, high on RAM, and its primary purpose is to cache the database queries. So whatever the server may have queried from the database, the result is cached here. It is high on RAM, so it is able to store a lot of things in the memory itself. And so next time the server generates the same query, the query will not go all the way to the database, because database has some disk access. We want to avoid disk access. Even if it is SSD, you still want to avoid disk access, because SSDs are slower compared to accessing from RAM. So if you want to repeat a query, the second or third query, which is not changing, is going to get the same result, you want to get that query reported to you from a service like Memcached, which is an open source product. Another product very, very similar is called Redis, another high memory data store. So let's go see both of them quickly. And there is a question: how do you set the expiration for cache items? In the header, and I'll show you how. And so we'll see that header for every object in the HTTP header. And I'll give you examples. So the idea would be, in our Redis and Memcached, these two products are very popular in the industry. One of them is Memcached, and that is this product coming up. It's a distributed memory object caching system. It is open source. You can run it very easily. All it takes is just a machine with lots of RAM, and it runs in Ubuntu fairly easily. Another one is this Redis. Redis.io is another product, open source, BSD licensed, and there is a certificate error apparently. Okay, so this product Redis product is also fairly easy to run, and you will find that many large cloud services providers will run services that will help you with this idea that I'm talking about right now, which is database caching. These two examples. Uh, Instead of running it on your own high memory server, you could just rent a service and substitute all of this. This red colored item you can substitute by renting a service from big cloud companies. So you don't have to run this extra server, and you just use a service, and that service is called, I think they have a name for it. Let's go find out what the name that Amazon uses, and the name is, click, Elastic Cache. And that caching, Elastic Cache caching, is basically implementation of Memcached in the Amazon service. So they give you this service. So when you click on the get started, and what you do is basically choose Memcached, Redis, or any other types of services that you want to create. And you basically create here a Memcached service, or here you click to create a Redis service, and then you get a ready-made service to use. You pay for the service. You don't have to maintain a server, don't have to do setup anything. You just get the endpoint to use it, and you go ahead with reducing the number of queries that are repetitive in nature. Avoid going to the disk. Even if it is SSD, it is still slow compared to RAM, and so you can expedite response back from the database queries a little bit faster. In fact, up to 10 to 15 times faster, because RAM is about 10 to 15 times faster than SSD, roughly speaking, depending on the type of RAM and the type of disk. So that's another way that people need to understand that you can improve performance of your service to the end user by cutting down the number of queries that need to go access the database. That's one technique that people will use in this context that I'm just describing.
Hey, Nilesh.
Yes, question.
Okay, yes, you mentioned, in the Slack, something is in the HTTP header. What was that again?
I will demonstrate that with a live example. And coming up. So let's go see the header for an example picture. So we have this guy. You need to have an object to deal with, right? So we are going to find a good object to talk about. And this guy is right click, copy image address, and that is Alexander Ramos. Let's go see what is the header showing up here. curl-i. And here are the headers. And here you see that let's go take this. So we'll go Alexander Ramos and his object that is sitting in the, let's go read this. That's the header, for example, in 18 lines. Okay, let's go edit this a little bit. Click, click. Yeah, there we go. So if you see, line number 1 is the command to grab the headers. And line number 4 all the way through 20 is the result, the header itself. This item called Alex Ramos -150x150.jpg is a previous Cloud Genius graduate. It is his picture here. And it is sitting in an uploads folder inside WP content folder in that server here. And we are accessing it with the HTTPS secure protocol. And we are trying to find out the headers for that particular object. This is how a browser will actually find out information about the item that is getting received in the protocol used. The server that is sending that data, which is this image, is Nginx server 1915. The date and the content type turns out to be an image type, JPEG. The content length in number of bytes, 4992. Connection, you want to keep it alive. Last modified date was January 15, 2017, when the picture was apparently uploaded. E-tag is a tag associated with the item. Accept range bytes, cache control, max age, and that's the age defined. Now let us see, the age is this. So how many seconds here? Let's go see that number. Convert seconds into year, and we will go type that number, boom, and you get 1 year. So the cache control max age definition defined for Alexander Ramos JPG was 1 year. Like I mentioned in the example before, the line number 13 sets the cache control maximum age for this picture for 1 year. And the expiration date turns out to be exactly 1 year. So Wednesday, 25th April, 2018 at 6:41 GMT. That's the time when I ran this command, curl command, plus 1 year, 2018. Today is 25th April, is it? In London, yes. In London, it is 25th of April, and the GMT time, and it is about 641 in London. And so it added 1 full year. There are certain other characteristics mentioned in the header, the core idea about when should this be expired is given in line number 13. That I think gives you an answer in your Slack chat. So here is the answer to the Slack chat request, and the header is this example.
So to follow up on that answer,
yes, please.
So I'm familiar with the concept of, setting the header as a part of the HTTP response or request, I guess. But as the person who's providing the image, how do you set that time interval? Because I'm just familiar with, like if you're a user, you're making HTTP request, you have that information, or you have like a header in your request, and that's something that the user provides.
Right. The user will provide a request header. This is a response header.
Oh, this is a response header. Oh, got it. Okay. And that's set by because as a provider, hold on, the response header is created.
Response header is set by the server in line number 5.
Right. And so how do you control that?
How do you control it in code? The code is written in line number 18.
Okay.
So the code is called W3 total cache. That's a piece of software that I use. That's line number 18.
Yeah.
And that's what I use to control this expiration. And I get to define who or which object gets what expiration. So I can set that. I can show you a live example right there. So I have disabled that, by the way, right now. The expiration still works, but what I have done is disabled the content delivery network capability of that, just to be able to demonstrate these things to you. And so you can go in here and look at the piece of software that I'm talking about right now, which is about caching. So we'll go inside to the back end and see if we can read a little bit about what I am discussing in a live example. We'll go to the plugins installed. The plugins I use is line number 18, which is called W3 Total Cache, which is another open source product. You can see the product here in web browser. It's opened up, and here is the plugin that I use, which is an open source plugin from this person, Frederick Towns, and all he does is this plugin. That's a pretty impressive personality. His plugin used by millions and maybe tens of millions of people use it. I am also using it, but right now it is disabled. So here it is, W3 Total Cache. And I'm going to activate it for you. It might cause a little bit of hiccup in the website. I just am cautioning everybody, as a consequence of this live change I'm going to do, it might cause a little bit of hiccup on the Cloud Genius website. And if it does so happen, please tell me. I will revert it and clean it up later. But I am going to take that risk right now to activate it to demonstrate a point. So I just activated that plugin. It will go and activate a bunch of caching, a bunch of content delivery network capabilities. You will see that live right now. I think it should be ready by now. So let's go see the consequence of this activation, and also read a little bit of where these things are set. So I will go and talk about performance. And so in the performance section, you have general settings. That's the segment I will go to first. So in the general settings, you will find that this gentleman wants me to, sign up, and yeah, I will do that later. So here we go. Let's go see now. Page cache, object cache, browser cache. Click. So here I am enabling browser cache. There we go. So it's as simple as a flag that I need to enable, and enable HTTP compression and add headers to reduce server load and decrease file load time. That's the idea behind this browser caching. There are tons and tons of feature capabilities in this particular piece of software. I am just focusing on one segment right now, browser cache. Now let us go see the other one also, which is CDN. In CDN, what I'm doing is host the static files within your current delivery network, within your content delivery network to provider, sorry, read that again. Host static files within your content delivery network provider to reduce page load time. So I have enabled it, and I am using the CDN type Amazon CloudFront. There are, by the way, a ton of examples. Lots of the companies do that. In this example, we are just discussing Amazon. And so we have saved that already. And the result will be that theme files, media library attachments, CSS, JavaScript files, etc. will appear to load instantly for the site visitors. That's the idea. So that my server, which is this Cloud Genius machine, it doesn't have to serve CSS, JavaScript, pictures, nothing, none of that. It is basically a tiny little box that you may have seen before when I showed you my.vulture.com. It is actually a cheap machine running here in the, where did I go? Here, running in the Vulture Cloud. It doesn't cost me a thing. I mean, it does $10. But it's a small machine right there called 2048 MB RAM server, and it is my origin endpoint. And that's 2048 MB server will cost me like a $10 every month. It is running and it has accumulated these charges, but my average bill for this machine is $10. No kidding. It's a globally available site, and I'm spending $10 on the machine itself. And now you'll see that this machine suddenly has this capability of serving it globally because I covered it around with a CloudFront network. Now let's see the result of it, all of the impact of it. What did I just do? So let's go see that. I am opening the site again from the front end. And this time, all the content that is now being received is coming from the content delivery network. And I hope the activation went through all okay. And with that assumption, I am going to find out this guy again, our friend Alex Ramos. We'll go to right click on his name and grab the image address, copy image address, and go to a notepad. This time, make some room on the top and paste. And what do you see? Aha, it comes from a different location, not from the server. It comes from CloudFront. It's a different file, as you can see, but yeah, you can ignore that part. It is that if you want to, if you insist on going to the exact same file, I have to go and hunt down the file, but I hope you understand what I'm talking about. The file is a slightly different file, alexramos.jpg as opposed to alexramos-150.150.jpg. So slightly different file, but trust me, even that file is also in the CloudFront location. I can prove that to you by just going to that location like this. So I will go to my CloudFront endpoint, and off we go like this. And so here also you should see in line 3 in that CloudFront endpoint, you should see Alex Ramos 150. Let's go verify that. Open and paste and hit. And there is Alex Ramos showing up in its 150 glory. And here is Alex Ramos in his full glory. So this will be the full glory picture and coming up like that. And this is full glory, the full resolution that I have in the website. So this is full resolution, and this is 150 resolution. Both pictures are now being served by lines 1 and 3. Line number 5 is the origin where it actually sits. But once I enable caching and enable this browser cache, this cache, that cache, tons of CDN cache, all of these things in one shot with one plugin, I'm able to use content delivery network, browser caching, database caching, bunch of other things we'll talk more about in one fell swoop, but improves the performance of that site globally, worldwide. You can see that line 3 is a representation of line 5. And if you go try to look at this site and close down and maybe disable CDN one more time. So if I go back to my browser dashboard and disable this total cache business, W3 total cache application, the plugin that I have, I will go there and disable it, which I'm cautioning you again that it might cause you further somewhat trouble in accessing Cloud Genius website, but I am taking that risk one more time and disabling W3 total cache to prove a point. Where is my cache? And there is W3 total cache. I'm going to deactivate it. I just did. So my cache is disabled now. And now I will go back to a new browser tab, open up the Cloud Genius website, go look at Alex Ramos' picture, and right-click on it, and right-click and say copy image address, click, and go back to a notepad, and then place it in line number 7. Here we go. This time I do not receive the file from my CDN, but instead I receive it directly from the machine, as opposed to line number 1. I receive it from the CDN. I hope that clarifies, and I hope you understand the idea of caching at multiple levels. And I welcome questions at this stage. You can see that line number 1 and 2 are similar. You can notice that line number 4 and 5 are similar, except 1 and 4 are coming from a content delivery network. 2 and 5 are not. The headers will be the same, because the idea behind content delivery network is that it looks for the origin header and replicates headers as well. Let's go verify that piece. So I'm going to see the content. By the way, this content delivery network actually should be alive, even if it should be alive and well, kicking just fine, even if we have disabled caching, at least temporarily. So I should be able to go to the CDN endpoint, which is the CloudFront endpoint, and hit, and I should still see the picture because this is accessing the cache directly. I hope you get the point. I hope you understand what I'm saying. What I'm doing is funky in a sense that I have disabled caching. So this is the server. The picture Alex Ramos sits here, and I enabled CDN. Then I am accessing this Alex Ramos from here. And then I somehow go back and say, you know what? No, I don't want it. Don't want caching. So now I'm accessing the picture directly from here, but the cache still exists, and I can still access this picture directly if I want to, and also from here until the cache dies away. Eventually, Amazon will kill it because they will not kill it until I go back to the Amazon console and kill the service. So Amazon will keep that thing alive. And this picture will come directly from the server or through the content delivery network based on what I decide. The CDN layer exists whether I use it or not because I have configured it outside from the Amazon's portal. I hope that was clear and not confusing. Was it confusing? If that is the case, I would like to know. I would like to know. These characteristics are immensely important in delivering high performance end user experience. That's what the whole cloud thing is all about, is distributed globally all the way up to the end user. You can take your content and expedite for the user. That's the core idea that we are discussing, and I welcome questions if there are any, and I would like to take a short break right now.
Nilesh,
Yes, please.
we can talk about it when we get back, but how did you tell CloudFront to watch your server in order to replicate it?
Good question. I will discuss that just like we did the bucket, and we said, you know what, here is the origin, and put a CDN layer on top. This time I said, you know, here is my little server, and put your CDN on top. That's all I did. That's the only difference. It was the initial setup that I have done a long time ago. And before this class started, I disabled my caching to demonstrate to you live. And I did that. Then I activated my caching and my CDN and browser caching and all those things. And then I disabled it again one more time. And I might enable it again, but I'll decide what to do with it later. I don't want to cause trouble in your accessing the website. That's my primary goal. And my secondary goal is to improve performance without actually causing access trouble. So it might lead to login issues. It might, this CDN thing, when it comes in and goes away, it might lead to login issues. It might lead to caching issues. And so if any of you find that you are unable to log in anymore, or not able to log in properly, or page not rendering properly, I request you to please clean browser cache. I think that's a necessary fallout of the game that I just played, is that your cache may have messed up. So I would strongly recommend that you please clean your browser cache, and then things should be okay. If the problem still persists, please tell me and I will fix it. Right now I'm not changing much. I hope it did not cause any trouble, but if it did, here is the resolution. Clean your browser cache. That should fix the problem, if there is any. I hope not. And with that, I'll start a short break and we'll resume. So here is timer. 7 minutes. Hey guys, I'm back.
I'm back too. I lost my camera though.
Thank you. Thank you. I hope you can hear me. Checking for that. And good. Yeah, that's good. So let us spend a few minutes on any questions you might have on this caching idea, and I will talk about next thing subsequent to that. So this thing we discussed, you saw examples. You saw a couple of key ideas. I think key ideas need a summarization that will help clarify understanding of this concept, which is we have to make why is it not moving properly? Hold on. Okay, OneNote again. And expand. And now it's moving. Okay, good. So from the user's point of view, all the way to the backend database. So let's draw the end-to-end perspective and focus on the key idea we need to see and understand from a performance perspective what needs to happen. So the very back end, there is this database. There is a server in between. And then you have what will constitute is this is your public endpoint. Then you have content delivery network that caters to global audiences. This CDN is your virtual expansion to the globe, if you will. And on the user side, a user typically accesses your service through a web browser, although there are other methods of accessing it also. For example, they can use an app instead of a browser. That is also possible. Both the app and a browser will have some kind of a caching in here. Capability of caching is there already with every modern browser. Our idea will be to able to cache as much if we can in the browser itself, to the extent possible, and technically it should make sense. It should make sense to cache it. Sometimes it doesn't make sense to cache. For example, the issue that I think John ran into like earlier this morning, he was logging in and then logging in again and not seeing the member pages. That was probably because of me messing around with the cache. I'm admitting that fault. I was playing around with this thing just to be able to prepare for the session today, that I was enabling and disabling caching at that time when John was trying to log in. And he was probably not seeing this page, which you expect to see, where your member pages and the access to content was visible, because he was aggressively caching the wrong page on his browser because of me. It was my mistake. And that, I suspect, was the reason why John ran into this problem, where he was not able to access like early in the morning when I was messing around with it. So I disabled caching and also reset his password, and he's now able to access. And so a bad piece of cache here, bad cache, to the user might show him or her a wrong page. And that is a mismatched expectation, which is basically an error. So you try to log in, you see the page, you don't see the page. That's a problem. So it happens when it might happen when you have a bad page in the cache. That is likely the problem what John ran into. Now, that just mentioning that all caching is not necessarily good. You have to do it very systematically and understand what needs to be cached and what doesn't need to be cached. Now, that's browser layer. Then you have globally distributed segment known as content delivery network. They're basically a cache in a different fashion. It is also a cache, which is managed by some kind of a service provider, like you saw in the example. And the example in our specific case was Amazon. And so if you go to Amazon and look at CloudFront and look at this specific thing that we discussed, you will find there is a cache here, like this D6RQ, whatever that name is. This cache, this distribution matches the origin, which is the BA Cloud Genius distribution, that endpoint. So let's go expand it a little bit, and you will see that all others are like the other rest of these 4, 1, 2, 3, 4, the last 4 are probably some kind of a bucket. But the first one is a custom origin that begins from b.a.cloudgenie.us. And if you look at this particular distribution, click on it, the origin is a custom origin, which is the vulture IP address here. This IP address is the custom origin from a different cloud. Now go back here and you see the behavior, the general characteristics. You can also see cache statistics. And you can see that this seems to be getting a lot of requests. And there are some green items and some recent blue items. You see the blue items popped up here higher because of a lot of miss. The miss started to happen from April 24 all the way through April 25. You see the blue line go up, and blue indicates a miss. Miss increased because I disabled cache for some time, and then I enable it. When I enable it, lots of people are getting a miss because the cache is trying to refresh. So you see the misses go up. And over time, you will see the blue line will go down and green will go up, because if I keep the cache active, because it will all be hits over time, most of them. So errors, there are still 2 errors apparently, and 159 miss and 45 hits that you can see in this example. When you access a particular item from the CloudFront cache or the CDN cache, you will see that it will give you the same header that the origin has set. This is your origin. Whatever header origin sets, the same header gets transported over to the CloudFront Cloud Content Delivery Network cache. Now on the back end, here also there is another level of caching that is absolutely important and make sure that we use, and that is known as memcache, or caching in memory database cache. The memcached and Redis are 2 beautiful open source products that are in use in our setup. In this example, I am using a Redis server in the backend here, and I should be able to point out where that is. Is it Redis? Yeah, here. So there is an object cache. I'm caching through a Redis cache, which is included in the droplet that I have in this machine I have. It also runs a Redis server for me, and that is what I'm using to configure it to cache the queries that are stored in the database on the backend. So here's the database cache, here's an object cache, there's a browser cache, and CDN, lots of different ways of caching, all of them together bundled in one piece of code known as total cache. That's the piece that I just demonstrated. And that concludes our discussion from a concept perspective on using storage technologies in this fashion to expedite, to improve performance to the end user. There are still a couple more left in terms of technologies for storage that I would like to at least briefly discuss, just to complete the picture. And those are here. We talked about S3, but we did not go deeper with EFS and Glacier and Storage Gateway. So at least these 2 I can describe. This one I have no way to demonstrate the Storage Gateway because I don't have an actual pipe to show you. But eventually I will find a way to do that. If I succeed, I will show it to you. I hope not. I don't think I can, because it's probably a corporate equipment you have to bring and show it to show you a storage gateway between your company and the cloud. But let's begin with what EFS is, and then we switch over to Glacier, and then we conclude the storage discussions and jump onto the network capabilities of cloud, and we will go quite a bit in depth in understanding what those things are. And there is some required reading that I have mentioned in Slack chat that you may have seen. The required reading is CIDR, which is this page. You should read. And another one is private network. You should read that as well before the next session. Excuse me. Two links that I have given in Slack chat are about CIDR and private network. Please read them before the next session. That's what I suggest that you do. And so now we'll finish up the discussion on EFS and Glacier. What is EFS? Let's go understand this from a picture illustration perspective. I'm going to draw that picture in this sheet and erase some of this and then adjust my width, erase. And if you have heard of this thing called cluster file system, that is what EFS is. But if you have not heard of this or used EFS or cluster file system or network file system, you may find it new. So let's go discuss what that thing entails. So if you have a computer, let's say this one, you typically have a disk in there somewhere that stores some kind of a file system. A disk containing a file system might be NTFS for Windows, or maybe some other type in Unix, or some other type in Linux. So a variety of file systems are available that you may have seen. These are locally accessible. So locally, as in, I can go to C:/ in Windows and access the NTFS file system. I can go to, /home / whatever to go access the file system in Unix or Linux, like that. I can access my file system according to whatever system I am using, and these are all locally accessible. They are stored on the disk inside here in a machine. The disk is in the box. That's called a local file system that you may have seen already. It's very, very common. People do this all the time. Here is my file system on this machine. It looks like this. So I have a folder and a BitTorrent sync and applications and Chrome apps and like that. That's a file system. Now, you've seen this already in your local computers, but you may not have. I think the second idea which I'm going to describe is a network file system, which I think is, you probably have seen this. You may call it by some other name. You may call it, you may have seen something like this. I'm going to type it out. SMB:// some server / some folder / some file. You may have seen such a thing in your company. Or maybe if you're an Apple company, Apple user company, you will see something like this. Or if you're a Unix company, you will see something like this. So these three are protocols. This is the Microsoft SMB protocol to access a shared file system. So the Apple filing protocol. And the third one is a network file system protocol used by Unix and Linux machines. So these three protocols exist in the industry. There are others also, but these are the most commonly ones used. And people in corporations use what is known as network attached storage, NAS. You may have seen that. Network attached storage comes in big boxes from companies like EMC and NetApp and others that will give you access to a shared file system that you probably have seen this in your companies already. If you're not seeing this, let us talk about that. I'm going to assume that you already know what this thing is. But if there are some specific questions about it, please ask them away. But I will be assuming that you already understand these three protocols of accessing a remote computer storage stored in a Microsoft box. You can access it like line number 7, stored in an Apple box like line 10, and stored in a Linux box like line 13. That's my assumption that you already have seen this in some corporation, some corporate situation. You access the same exact folder and the same exact file in that same server through three different protocols: network attached storage, shared file system. That's the kind of concept structurally where we accomplish the idea that if you have a box, for example, here, and it has its own local disk inside, but you want to store the data, as I said, outside somewhere. So you provide this service from outside that anybody can access this network attached storage in a shared file system. Anybody, as in this machine, as well as this machine, all of them can access network attached storage comfortably in a shared fashion. Each one of them also has a local disk, but then we are talking about a shared disk, a network attached storage disk, shared disk. That's the kind of concept that we are discussing, which provides the ability to store data somewhere else outside and not on the machines themselves. Conceptually, that is the core idea behind EFS, Elastic File System. It is implemented structurally similar to this open source project called GlusterFS. GlusterFS, in a fashion, what it does is that you don't need to have this, but you use your internal disks right here. But then you manage it in a fashion that you share it with everybody else. So what does that translate to? It basically becomes a cluster file system where you get to use a shared storage space that is actually comprising of your own internal disks. It is there already with you in your machine inside, but then you put together and form a cluster of disks and treat that as an independent file system accessible by any of these machines that are participating in the cluster. This is the cluster. And the file system becomes Gluster. It's a cluster file system. That Gluster is just a name. This cluster is an open source product. I think I mentioned the last time, Gluster. And that is the storage for your cloud. So you can install this piece of software on each of the machines in your cluster, and that produces a separate file system, which is redundant, highly available. Even if one of the machine dies, no problem. You can always store the data to the other locations, and it is replicated, synchronized, and nicely done. That's the core concept behind this product called EFS. This EFS is basically an implementation of some variation of Gluster in the Amazon cloud for you. So you can just create a file system by clicking this button, boom, and that's it. You select your VPC and you select your availability zone that you would like to have. And then you next step and you have a file system ready for you to use. That's the simplicity that Amazon brings. Nothing much needed to set it up or configure, because they do the work for you, but they charge you money for it. So you pay as you go. You use the Gluster, use this Elastic File System as you go along. This file system becomes visible to your computer internally. So when you start these machines here, for example, and here in the Amazon cloud and create a EFS cluster, each of these machines will get access to a shared file system that they can operate on. And by using such a structure, you get the idea that your machines become disposable. Disposable. So that, this machine dies, no problem. You bring another one and put that back in business. And so this one dies, goes away, you put this one in place. That's all. That's all it takes. So you can add more, reduce if you want, scale out, scale in. The machines themselves remain disposable. You still have your storage intact because it is centrally managed outside, not on these boxes, but outside. That's the way to use that Elastic file system. It is a highly desirable service. Some clouds provide that. Not all clouds yet provide this kind of a service. I think they're developing it, but this is probably unique to Amazon right now. But don't make that make you feel that you cannot pull together your own solution that works just like that, because you have this choice of doing it your own. It is not a service. You still have to work to set it up, but then there are automation available to make things easy for you. You will see some examples like this coming up in the second and third segment where we will automate stuff. This idea of using a shared file system is a nice capability that is provided if you are using a cluster of machines to service a particular scenario. And that's the idea behind EFS. We don't have an exercise
So
to go ahead, question.
how is this different than? Is this the same as storage as a service?
Yeah,
Where
pretty
you-
much. I think I don't exactly know how they implement it, but my friends in Amazon tell me that it is this product implemented.
Yeah, so how is it different from S3?
Okay, so the question is, how is it different from S3? So if you see the distinction between this or cluster versus a bucket, and you put an object, there is a fundamental difference in the way a file system operates, and it is different from a object store. And I will describe that difference, and you will immediately understand why it is and how it is different. Let's say we have a file. It is called readme.txt, just a name. In that file, I have 26 characters. Those characters are A, B, all the way through Z. As I start to read this file in my file system, I can seek into the file. And when I am seeking into the file, I can read the character A, B, C, and give me the 8th character, please. And I will get H. I can seek into the file. On the contrary, in an object store, you get the whole object. You cannot seek into an object. It is the whole thing that you have to get access to all the 26 characters together as a one single object called readme.txt. There is no halfway through or get me the 8th character. You cannot do that from an object store. You cannot seek into an object. You can seek into a file in a file system. That's the fundamental difference. If you really want to find out the 8th character in an object stored in an object storage like S3, you need to get the object. There is no seek, as I said. There is a read function, there is a write function, there is a seek function. In objects, there is a get function, there is a put function, but there is no seek function. With that, do you understand the difference? It is treated like a whole, like a packet, like an object. You just dump the object in the bucket. It is not a file system. From a standard POSIX systems like Unix, you will find that you can seek. In Windows also you can seek. You can seek into a file. If it's a large file, you can seek ahead and go to that particular spot and read a portion from that segment. If it is a 2 terabyte object, let's put that in this bucket. You can put a 2 terabyte easily. I think the limit object size is, let's see, S3 size limit 5 terabytes. So you can put a 4 terabyte item in a bucket, and if you want to seek into it, no way. You have to bring the whole thing down, 5 terabytes, all of it, or whatever that size is. And then in your local file system, you seek. Once you bring it down, it becomes a part of your file system. If it is in the cloud, in a bucket, in a store, in an object store, you cannot seek it. There is no way. Then the seek function doesn't exist. That's the difference. Now, also a couple of things that about reliability and availability of these kind of services. Like, you have this simple storage service. They give you some kind of a crazy, obnoxiously large number for durability. And let's go read that, how much it is. So S3 durability, it's unbelievably high. Undurability. S3 durability, the claim is here. Let's go see the claim. 99.999. That's 5, 9, 6, 7, 8, 9, 10, 11 nines. And that's the kind of durability claim that Amazon has on its front page of the website, with durability claims as high as, where did that go? Yeah, here. Reliability and durability of 11 nines. That is a phenomenal claim if you think about it. You know, it's a feat of magic if you really think about what they're talking about. Is the kind of reliability and durability of an object that you put in a bucket is going to be what again? 11 nines. That means the chance of losing an item that you put in a bucket is extremely low. When they're giving you that kind of a guarantee and reliability, at what price? Let's see the pricing. AWS S3 pricing right there. The pricing is free for the free tier, by the way. And for other people, I think beyond a certain limit, I think you have 5 GB free in the free tier. But apart from that, the pricing is 20, no, not 23. It's like what? 2.3 cents per gigabyte for the first 50 terabytes. It's pretty darn cheap. Price is already cheap. And at that kind of a low price, they're still able to promise a 11.9 durability guarantee. That's amazing. Don't confuse this durability with availability. I hope you know the difference between availability and durability. The idea behind durability is that they promise that the data will be there in a bucket, safe, like safe, as in 11 nines safe, 99.9999 whatever number of 9% safe. There is still some chance that you will actually have a data loss. It's a very, very small, finite, non-zero chance, but that is too small and you can comfortably ignore it, practically speaking. However, availability is not durability. Availability means that you can actually access the object right now every single time, and if that is the case, it is 100% available. But that's not the case. You know, you cannot really practically guarantee availability of an object at that high level of number of nines. It is very difficult to accomplish availability at that level. Durability is possible. They have accomplished and they claim it. The idea behind durability is that your data will be intact and you can get to it at some point, if not right now. Availability means the data is there and you can get to it right now. That's the subtle difference between availability and durability. And there are other ELTs you may have heard of. ELTs, you can put the word here you like reliability, availability, serviceability, bring your ELT. That's the whole idea. This word RAS was created by IBM in about 40 plus years ago. That's where these things came from, and people measure it. That's a measure of service quality, and so that's another ELT. The idea is you have to understand the difference between this and this, and I hope you do. If there are questions on this, please make sure to ask them. Now, having explained this idea about difference between file system and object, let us now discuss the last type of storage, which is in here. It is Glacier. This Glacier idea of storage is slightly different. It is kind of sort of like this. By the way, the usage patterns for Glacier are archival, long-term archival. You want to archive your data for long-term, like 30 plus years, that's where you go and store your data in a Glacier. The idea is it is large, and it is going to be there for you for perpetuity, and also it is cheap. It is cheaper than a bucket, probably 1 to 3 times cheaper than a bucket. So it is cheap, but there is a catch. The catch is that here is an island, and that's where you store stuff. Going to the island is free. Coming back from the island is not free, because there are alligators all around. All around the island is infested with alligators. Going there in a boat is free. Staying on the island, on the glacier island, is cheap. Coming back out of it is not cheap. That's the catch. You need to understand this. The reason I describe it this way is that the idea is when you go to the island, the idea is you are backing up, or you are archiving, you're storing stuff. But now comes the audit, and you want to retrieve. The retrieval is not going to be free and is going to be slow, painful. How slow? Let's go see that. How slow? So we'll go ask Amazon, how slow is AWS? So the retrieval policy, let's go read their policy or retrievals. So I think it takes like 3 hours from you telling them I want my data and they giving it to you. Like 3 hours. It's a very, very slow process, painful. And that is why there's a name for this type of storage. I cannot really call this online storage because it is not truly online. I cannot get to it any time I want. I have to ask for it, place a request, and then it will become eventually available. Then I can go and access it. So there is a phrase for it called nearline. And that's the name that industry has been using for many, many years. Classic old style storage of using tape backup was like this. So this is conceptually like tape backup, if you will. Some people tell me that they use optical disks here, but I'm not sure. My suspicion is Amazon as a company has been doing this cloud business for 13, 14 years. And even before that, they had this Amazon.com retail business. So they have a ton of capacity, hard disks, slower hard disks from older generation, magnetic disks, that they are probably using it as, basically refurbishing it as a storage solution and using it for long-term archival. And that is what my suspicion is. I don't exactly know. They don't tell us as to what technology they use to store it. But the idea of using old hardware for nearline storage is a good one. And that's the service that you see in case of Amazon's Glacier. Now, what competition has done is, for example, this guy called Google Nearline Storage is what they have done, is prepared a solution for Google-based storage solution for archival, which is very, very beautiful compared to what you see in Amazon's solution. And the idea is it is also not really online. It is also cheap, but a nearline storage will become available to you almost immediately from Google. If you go to Glacier, they might take you 3+ hours to retrieve the data and then make it available to you when you want to retrieve. Whereas Google says you can almost readily access your nearline data as well, which gives these guys a competitive advantage. It is quick to retrieve, just like a nearline, just like an online storage would be. Online storage is roughly about 2 cents. Nearline storage is roughly about 1 cent, approximately speaking. That's the pricing comparison they are given here. Whereas the pricing is similar with Glacier, but Glacier retrievals are slow. And you use the scenario behind storing these things are predominantly used for long-term retention of required legal data, or something else the corporate policy might require. Airplane designs from last 30 years, you just store them, archive them in a central location like this. That's the kind of usage model where you have a huge bunch of data that you want to just dump it somewhere, you dump it in the cloud. But remember, retrieval is not cheap. They will charge you an arm and a leg sometimes. And it is also slow. So just beware of that. Having discussed these things, other cloud services also provide, I think Microsoft also provides something similar to this conceptually. And what I wanted to discuss with in the storage aspects is using this is not like a easy interface. If you can go to Glacier in the portal, you will not find a way to access the file you store. If you go to Glacier, like click, you have to first of all create a vault, and you have to name it, and then next step, and then you start sending your items to the vault. It will go and sit there in perpetuity until you ask for it. Then you ask for it, and you have to retrieve it through a command line interface. It is not available to you on the web browser at all. Just want you to know. Compare that with Google. Google makes it easier. So there is some catch up for these guys to do from a retention archival perspective. But again, these kind of technologies are not that a mainstream use even today. People still use Glacier, but it is not as interesting as storing in a bucket, because bucket is easy to retrieve and also almost as cheap as storage. So the pricing makes bucket storage attractive. I have seen most companies use buckets, either Google Bucket or Amazon Bucket or Microsoft Bucket, and store the data right there in the bucket. Don't bother about Glacier type stuff. But then certain corporations use it. I'm not saying that they don't. Having said, the usage patterns of these technologies are somewhat similar to what you may have seen already in your day-to-day usage. For example, many of you I know use tools like Dropbox or Google Drive or OneDrive, LiveDrive, whatever that name is these days. What's the name? OneDrive. And so these technologies, Box.com, these technologies in turn actually use storage in a bucket, some kind of a bucket. So for example, S3 bucket, Google bucket, Microsoft bucket. These technology providers will provide you access to buckets, and applications like these will make use of the bucket storage, object storage solution to construct consumer storage solutions, consumer storage in the cloud. That's the storage scenario that most people think of, like iCloud from Apple, right? iCloud. iCloud is a storage solution. It's a very expensive, for no reason, a ridiculously expensive solution for storage, iCloud.com. But up until a couple of years ago, iCloud was actually stored in the Microsoft Azure Blob Store. And you could see that when you see traffic flowing from your iCloud application, you can trace the traffic route, and you can see that it is actually going to Microsoft. Microsoft, when it was new in the Azure cloud, got a great deal having Apple to sign up to store iCloud data in the Azure Blob Store, because Azure did not have much traction in the market. So they were able to get a throwaway price to Apple, and Apple took that thing easy. These days, I think Apple has its own storage solution that they don't use Microsoft's cloud because they have built their own capabilities. Now, these technologies here that you see in the consumer storage are different from what we saw in the bucket technology that you saw in a couple of examples. The simple difference between this technology on the consumer side versus this technology on the developer side is that it gives you programmatic control here, whereas these things are more like user friendly. So you can see examples like This thing is the Google storage application, which you may or may not have seen. Google Drive. You can click through and see the settings for that and all that good stuff. I'm sure you have seen this. I don't need to describe this to you. I'm assuming you already know what I'm talking about. For example, here is Dropbox application, and here is the the preferences for that application. So I'm assuming that you already have seen consumer storage, and I don't need to walk you through these things at all. So I'm going to skip that. And that's a fair assumption, I suspect. One quick comment on this about consumer storage is here. So the fact that some of you have taken advantage of, and I did never discuss this with any of you, only briefly mentioned it a while ago, and I would like to talk about that briefly, is this idea. So storage.google.com. No, where is that Google Drive? Google Drive. So what I'm basically saying is all of you have access to unlimited consumer storage from Google through Cloud Genius for free for, I don't want to say ever, because Google decides that. But if I go here for you, and if you log in as Cloud Genius, you will notice that everybody in Cloud Genius gets access to unlimited storage. This is a claim that Google is doing, which means you can actually make use of it even after the class is over. As long as Google remains in business, they are going to give it to you, and you can make use of it. I know a couple of you already use it. If others are interested, please let me know. I can enable this for you, and you can get unlimited storage. This is not a joke. This is actually true from Google. They give it to you and me because we are a part of an educational institution. So take the benefit if you're interested. I personally store 5.31 terabytes of data. And you can also store it. It's up to you. I'm just mentioning that. If you're interested, ping me, Slack chat. Google and also Microsoft gives the same, but it's not unlimited. It's like a couple of terabytes. But I think unlimited is better. So take the unlimited if you're interested. Don't have to. It's totally optional. And don't use it with your corporate account. This is like a school account. So don't mix it with your work. Keep it private, keep it to you, and use it according to the Google terms and conditions. That's all it takes. And if it goes out of business, don't call me for help because I cannot do anything about it. So if Google goes out of business, too bad. Having said, let's move on to the other topics, which are going to be focused on network capabilities. And we will begin discussing some of the core ideas in this concept of network capabilities in the cloud as provided by a variety of network solutions in Amazon, Google, Microsoft, and a bunch of other clouds. But before we jump into that segment, which basically starts in module number 11 in the cloud technologies, which I think I mentioned a couple of sessions ago, that you should review the cloud technologies segment, module number 11, very carefully, which is this begins here. You should absolutely review this segment ahead of time. Before the next time, there's a chat request. And okay. Yeah. Oh, I see. Count me in. I see what you're saying. So what I am noticing, a couple of you are interested. So I would like to clarify. It is tied to your Cloud Genius email address. You have a password for it. I need to make a couple configuration changes to make sure that you are able to successfully use it. But Cloud Genius email address password is controlled by Microsoft, and this Google service storage is provided by Google. So you have to basically make sure you have to see how it ties together. That's what I would like to do. And you cannot tie it to your personal address. It is given to a school address. So Cloud Genius is a school. So that's why it cannot be tied to a personal address. And other questions. Okay. So the link I just pasted is something you should absolutely review before the next time. And today I will begin discussing the idea of a network in the cloud. Basically, it begins like a private island in a cloud. So I'm going to change the piece of paper here, grab a new sheet of paper, and then talk about the concepts of network. Some of the fundamental concepts we need to discuss here is around isolation, security, and about addressing, routing, and flow of traffic. And all of these things can sound nebulous unless you see an example. So I will begin with very simple examples that most of you already seen it. Beginning with that. So here is you, or think of me, or it doesn't matter, any person that lives in a home. You have a home here, some kind of home like that, and that person is living in the home, and they have some kind of an ISP, internet service provider, that gives them a pipe. This pipe basically carries data this way and that way, both ways, bidirectional data. And this ISP typically gives you a public IP address. Do you know how to find out your public IP address? I bet you do. I bet you can go here and say, what is my IP? And it will give you your IP address. My IP address is this. And so that is my public IP address. Is it the same as my laptop IP address here that I have? And maybe this machine I'm using right now, is it the same as the IP address of this machine? What do you think? And the desktop I have here, is it the same as this IP address of the laptop desktop?
No.
No. Correct. No is the right answer. So this IP address that I have is assigned to my router. It is my public IP address. Whereas this machine here, a laptop and desktop, these guys have a different IP address. What do I have? Let's see. So in here, I have this IP address called 10.0.135 and another IP address for this network card, which is 10.0.1.4. And then I have a bunch of network cards here, but an iPhone network card, an iPad network card, and a bunch of other things connected and some other not connected. And so I could get another IP address just by clicking this and enabling it. That will enable tethering. And if I enable tethering, I get a third IP address on that endpoint. So I will have 1 and 2, and then a third one here if I enable tethering like this. And so if I apply, it will receive another IP address on, I think I need to connect the wire. So I'll have to get that phone and tether it like this, and I get a third IP address pretty soon. And there it is. Okay, and network again, please. And here's my third IP address is 172.20.10.3. So I got 3 adapters, 1 with this address, 2 with this address, and 3 IP addresses on this machine itself. But my public IP address is something different. 73.59.110.24. Let's go compare notes. So we now have this IP address, and now I have 10.0.1.4 and 10.0.1.35 and 172 dot something else. And what was that? If this discussion is too simple for you, please tell me. If it is, if you've never seen these differences between public and private IP addresses, you should watch and carefully and understand what these things are. And so if it is too trivial for you, please tell me so I can speed up. If it is new to you, I will spend some time and elaborate on what this is going on and how is it relevant to a cloud context. Okay, so I have accumulated my IP addresses here. This is my Wi-Fi. This is my Ethernet card. And this is my iPhone tethering. And this is my public IP. Okay, now what is going on here? By introducing this iPhone, I have basically connected a separate connection different from my internet provider. A separate cable connection, sorry, a separate internet connection different from my internet provider. I just established that. So what I'm illustrating now is another picture drawn carefully. Like this, I have this machine here, and I have a Ethernet card and a Wi-Fi card These two go to 10.0.1 whatever address. This whatever can be 4 or 35 in my example. 10.0.1 and then whatever. And these two are the Wi-Fi and Ethernet. And these in turn are connected to a router that is connected to a cable modem. And this cable modem is connected to a cable from Comcast. That is my internet service provider. The address I receive here is my public IP. The address I have here in this point is a statically assigned private IP, 10.0.1.1 on this leg of the router. The router has two legs. One leg is the public facing leg, and the other leg is internal facing leg in my home network. So that is my internal network. And in addition to all of this, what I just did is connected another adapter, iPhone, tethering. And it gave me a separate 172 dot something address. 172.20, this number, 172.20.10.3. 20.10.3. This address I received from my iPhone. Now this tethering actually happening through a layer of network address translation here within the phone, and it is connected through T-Mobile Wi-Fi. T-Mobile, not Wi-Fi, T-Mobile network. It is like Comcast network ISP. It's a separate ISP, so I have two internet services providers connected simultaneously to this machine where I'm working right now. I am here. Now, if I disable tethering, I will disconnect this route to the internet, which is very easy to do. I can just go back here and say, you know what, iPhone, disable unless needed. So I disable it and apply. And iPhone gets disconnected. Still, it is still attached by the cable. You can see the cable is connected, but internet is not used. So now my picture changes. I'm strictly within my Comcast company solution. So right now, this green segment here is disabled. So I'm not going through the T-Mobile network at all anymore. Now, let us go understand the private segments here and the public ones and distinguish them from each other. The T-Mobile network here also gives me another public IP address at this point. The router in my iPhone converts that into a private IP address inside, which happens to be this IP address assigned by the iPhone tethering adapter to this device. So this is the private segment. This is the public segment. The segment that separates these two is a capability known as network address translation. This NAT is a part of your router, and it typically does distinguish and separate the public area from the private areas. Now redrawing the picture one more time in a slightly simpler fashion. We have a piece of hardware or sometimes a piece of software that does this idea of network address translation, which basically translates public into private, and they basically provide a way to connect the two together. A public internet address space can be represented by these four boxes. These boxes, the values in there can range from 0 through 255, each one of them. That's the kind of addressing scheme that we have on the Internet IPv4 addressing scheme, version 4. That's the scheme we have in the Internet today. If you go like this, you will receive about 4 billion addresses. If you expand all this from say 0000 all the way through 255 like that, you'll approximately receive 4 billion addresses. 4 billion on the internet is too small. Cannot fit every single device on the planet on a public IP address. And that is why a new method has been created through a standard known as RFC 1918, if I remember right. Let's go check, verify. There is a standard here, RFC 1918, and that standard defines private networks. And that is the standard, this one, which is, you can read this, it's a very nice reading. It's a IETF RFC, request for comments. You can read that later, this one. And the whole idea behind all this discussion is that people in the standard have reserved a certain set of numbers out of this 4 billion. It's a carved out segment, carved out portion, and they treat like private. It is treated like it's a treatment. It's a generally agreed upon principle that any addresses in the range 10 dot x something dot whatever will be considered a private network. That's a part of the specification in this standard, RFC 1918. In addition to this carved out address space, there are two more that are carved out as private addresses, and those are coming up. You don't have to remember these things. You can just always search on Wikipedia and find it. And so here are the two other ranges. The two other ranges that are classified as private ranges according to the specification for RFC 1918 are the range 10,000 all the way through 10 to 55 to 55 to 55. That whole block of range contains about 16 million addresses, has been set aside, demarcated to be known as a private area. Similarly, the address range 192.168.0.0 all the way through 192.168.255.255. That address is very small space. It's only 64K addresses. This space is kind of narrow, but it has been very, very commonly used in most homes. You will find your IP address is probably in this range. Most homes will have a router, will have an address space in this range, private address space. That's a commonly deployed scenario where most routers select a subset of this to be specific as the private segment of the network that people will have in their homes and small offices. The limit here is 64K number of addresses. And in addition to these two, there is a third one, which is also called out as a private segment, which is 172.16.00 all the way through 172.31.255.255. And that segment is also private. So 172.16.whatever all the way through 172.31.whatever. This whatever can mean 0 through 255, any number you feel like you can fit in. And that range, this range from here to here is also considered private address. You can notice that, if you look at my iPhone IP address that I got internally, this item is a 172.20.whatever. And this 20 fits in nicely in that range between 16 and 31. 20 fits right there. And that is why I know that the IP address assigned to me by the iPhone tethering is also a private address because it fits into this range. So these three ranges are defined as private area. Everything else is a publicly addressable, publicly routable IP address. That's something that I would like you to very clearly understand. And I hope this discussion clarifies that piece in terms of distinction between public segments and private segments. The reason we have this kind of a distinction is that in your home here, and my home here, and our friend's home there, each one of us can have the same 192.168.2.23, just like that. Each one of us will have this, could have, 23, 2.23. Each one of us, me, you, and our friend, and anybody else could have the same exact address on their iPhones or their laptops or whatever, but they will not be, superimposing on each other. They are not colliding. They are not routable unless you are inside that home, inside that office, inside that location. So if you are here, you will reach this machine, which has this IP address. If you are here and you try to go to that IP address, you will reach this location in your home. If you are in this building and you are in that location and you try to reach 192.168.2.23 attempting to address your friend's computer, too bad. You will not be able to route to that location. It will take you to your internal address 192.168.2.23 in your private area. These private addresses are not routable from outside locations. You can route to them only when you are inside that location. And multiple people globally can have the same address, provided they are limited to a segment, like your home, for example, or your friend's home, for example. You are basically bound by your firewall or your NAT network, NAT subnet. Now let's go see what does that mean. In every home, you may have seen, or you probably use it already, this thing is called router. It looks like this. In a typical router, you will have a port. Let's go back. I think I did not open right. You have a port like the yellow one. It says internet. And then these other ports, blue colored ones, 1, 2, 3, and 4 ports. These are internal ports inside your home, inside your office. The internet port, this one is typically connected to a cable modem or a DSL modem or some kind of an internet connection service provider device, which goes outside your location, outside your building, outside your home or office, that one. These ones, 1, 2, 3, 4, are provided access to the internal network. The scenario would be that you will bring a device like a Comcast router, for example, and the Comcast router will be something like that gets a cable connection here, and then gets a Cat5 out. Cat5 is the Ethernet cable. And so here you are ready to receive a public IP address. Now, in most homes, you will find that people will take a computer and connect it directly to the public IP address. Is that what you see out there in your friend's home? Is that how you typically see? That you get a laptop connected directly to a cable modem through a Cat5 Ethernet cable and get a public IP on the laptop itself and done. Is that how you see most of the deployments? Anybody? Do you ever see such a thing? You could possibly do that connection and it will work. Nothing wrong with it. But do you see this? Like people connecting their laptops directly to a cable modem and just go to the internet.
No.
You don't see that. Do you know why you don't see that? Do you know what's the problem with this kind of setup? It works, by the way, technically accurate, and it works and everything is good. Nothing wrong with there from a technology perspective, but why do people not go set up like this?
Wouldn't you both have the same public IP?
There are both as in who?
Well, if you have two computers set up to go through the,
Okay, so yes, you bring a very, very, very valid point. What if you have two computers? So in this example, the person had only one computer. There is no other machine he or she has. So in that case, if you need to have two computers, you need to have a method of dividing it like this, and then public and private and private. And then you can connect 1 and 2. And that's a good one. That's one reason why people use a router. But what if the person has only one laptop, nothing else, absolutely nothing else, and a cable modem? Should they still use it like this? Technically, yes, it will work. But what are the reasons why you don't see that? And even if you have just one laptop, people don't recommend it. Do you know why?
Security.
Security. Bingo. So the other idea behind this idea that you saw that a router will do is it'll expand the address space to allow multiple machines to connect. In addition to that idea is this idea of security, which is the idea of a network address translation is one aspect of it. The other aspect of it is a firewall aspect of it. And there are a bunch of other services that are built into routers. Routers are basically combination devices that put a variety of things together to provide a variety of scenarios. For example, address translation, addressing public segments into multiple private segments internal to a private subnet is this function called network address translation. There is typically every router will have a firewall to help with security. And that is another scenario that you need to protect yourself, your single lonely laptop, from the evil guys on the internet. Let me tell you that they exist. They are there. And they hit everything they can on the public internet at the public IP address endpoint. They hit hard. And it is not a joke when people talk about Russian hackers, because I see them every single day. And we have a bot to prevent that. But people from, I don't know why Russia, but yeah, they're not just Russia, other countries also. They just show up and they hit hard on public IP addresses. And I see it every time I go and examine the logs. The idea is people out there who are out to attack you. And it is not a joke. It happens. And you want to prevent that. And therefore, you want to put some kind of a protection, and having a NAT protection, having firewall and other capabilities in form of a router device that kind of sort of looks like this is what is necessary and is recommended that people apply. And that is what we will be using in the cloud. In the cloud, we will set up something pretty much like this. We will have a router, a NAT device placed in the cloud, and we'll configure just like we do in our home, by the way. Just like in our home, you will have bunch of machines, here's machine number 1, machine number 2, like that, machine number 3. Each one of them needs to get a private IP address. And you know what? If you are outside, you should not be able to access any of these machines at all. That scenario we need to set up. We need to also have a method of network address translation that will basically have a method for people from the outside to be able to not get in to machine number 1 or machine number 2 or machine number 3, like that. Whereas people who are sitting inside your location, M2, for example, if they want to go visit CNN.com, they should be totally okay with opening a browser, asking the router, hey router, can you please get me CNN.com? The router will then pretend to be M2 and tell CNN, hey CNN.com, I want to see what you got. I am M2. It is lying. It is totally lying at that moment, pretending to be M2 and saying, I'm M2, show me CNN, what do you got? And so CNN says, oh, M2, here, take a look, what I got. And it shows up. So this is what you see. So CNN thinks M2 has come asking, but not really. It is a gnat who is masquerading as M2. This masquerade business is what gnats do. It pretends to be M2, and then when CNN responds, hey M2, here's me. And so then that now router will take that content and send it to M2. This masquerading happens all the time. That's what routers do. That's what NAT does, by the way, NAT. Routers are bigger than NAT. Routers contain many other functions. We are just talking about the one function called NAT. That's what a router does typically, is cheat, lie, pretending to be M2. When M2 asks for it, it says, hey, I am M2, show me. And then it gets the result back and shows it to the M2 machine. At the same time, this M1 says, you know what, show me New York Times. And so router suddenly becomes pretending to be M1 and goes to NewYorkTimes.com and says, you know what, show me what you got. I am M1, cheating again. And then getting access to the content from that site and sending it to this guy. So that's the kind of idea behind internal people allowing them to go out, but external people cannot voluntarily get in unless you ask for it. Unless router is asking, hey, give me CNN, what do you got? Then I can get it. And I let CNN traffic go into M2 and let NY Times traffic go into M1, but not without permission from M1. It has to originate from inside. NY Times on its own cannot just venture into M3 and say, I want to see what you got, M3, show me. So too bad. The traffic from outside, from random place, attempting to get in, will be rejected right here. No route to M3. M3 is a private IP address. So is M2, so is M1. It is not routable. Cannot go there. Cannot go there. This concept, I think you probably you live with this every single day. You know this. But I'm just calling it out in black and white to understand, help you understand these elements of who is doing what in terms of understanding network flow of traffic. That is important because we will now that we have discussed your private home scenario, we'll extend the same idea to a cloud. In the cloud, a typical setup that we will discuss, and we'll build upon this idea in much more level of complexity in building your data center in the cloud. And so in your big cloud, some cloud, you can build your own private data center, entire data center in the cloud. And to enable that, you need to be able to treat like private area. And to enable that setup is what is the basis, the foundation that I'm starting to build. Is think of a private cloud within a public cloud, like public cloud like Amazon or Google or whatever, is basically a subset of the public cloud that you configure as if it is your own home. Think like that. It doesn't work like that, actually. It's not a home. You cannot even go there. It's not home. But mentally think just like this, that it is your private safe area, that nobody else can get in there, that you are only there, but nobody else can, and you can originate traffic from inside, but random traffic from the outside cannot go there, and you have to have a NAT device and a private segment and a public segment and all the capabilities that you would like to have in your real data center in your company, just like you have in your corporation. Exactly that you will be able to create in the context of a public cloud. And that is the core idea that we will begin discussing next time, which is to create your own virtual private cloud, which is going to be constructing a full-fledged data center in a cloud. That's what we will be doing. You can, of course, create a real public, sorry, say it again. I'll say again. The idea will be to create virtual private cloud in the cloud, as in public cloud. That's the idea we are going to build, virtual private cloud. And this you can construct inside like your own data center. And this is going to be virtual private cloud, meaning it is actually in the public cloud. It's not really a real private cloud. A real private cloud is like your OpenStack implementation in Boeing, OpenStack. Now that is a real private cloud. You have a physical building and you're setting it up and all that. That is a real thing, real private cloud. By the way, nobody actually uses the word real private cloud for private clouds because that is implied. But when you put a private cloud in the public domain and still make sure that it behaves like a private cloud, that's when you call it a virtual private cloud, also known as VPC. This VPC example references you can probably see in multiple cases here, and I may have used it before, and you can see that here, and I told you not to delete your default VPC and all that good stuff. That's what we'll start building. To build a VPC, it's very, very simple. All you do is click this button, boom, and select, and then you're done. There's one more button, the blue button here, and then you create a VPC. That's all. It's automated for you. And that is not how I want to do it, because if you do it this way, you will never understand what's going on under the hood. So don't recommend this approach right now. I would recommend that you please review this segment that I think I already mentioned to you in Slack chat, which is, where is that? Yeah, this mention I have here, the link I just posted, click, and that link you should watch absolutely ahead of time, before we meet the next time, because that's the direction I will be heading. And some of it I covered it today, but I suggest watching the entire module 11, which is unit number 1 through 16, all of that. These are short sets of videos. Some of that may or may not make sense, but it will help you understand when I will give you live examples the next time we meet, which is going to be 26th, Wednesday. And that's when we'll meet at 4 o'clock. So the idea that I'm basically building on towards is the concept, which is going to be here, is to build a virtual private cloud from scratch by really understanding step by step as we go along, understanding the concepts of subnets, understanding concepts of security groups, understanding and putting our own router as in a NAT device, understanding routing of traffic, creating route tables. And some of these things are new to most of you, I understand. So if it is new, just hang tight, watch that video series, and let us go through examples. Now, one thing that I mentioned, which I think will help your understanding in case of the idea of security groups, is something that I'm not sure how many of you are familiar with, but I'm assuming some of you are, some of you are not. And so the idea of a security group is something that I would like to spend 5 minutes before we have still about 10 minutes or so. Yeah, 8 minutes. So I would like to spend some time on discussing this concept before we get into the next session, in which we will have an exercise and build things around, is the idea of security groups. It's kind of complex to understand, so I'd like to throw some ideas here, is to help you in accomplishing this idea. So a security group essentially is a collection of rules of traffic. It is a collection, meaning there are lots of rules. Rule number 1, rule number 2, rule number 3, like that. You will have lots of them, rules defined. And it basically goes like a rule. A rule will be something like, you originate from where? The traffic. It's a traffic rule, right? You start from where and you want to go where, and you want to use which port or which protocol, and whether you are allowed or disallowed. That's the kind of a rule structure that you have to put together. Whether you're allowed or not allowed to originate traffic from this location, to take that traffic to this location through this port number or this protocol. That's the kind of a rule definition, and you put together a collection of such rules that constitutes a security group.
T2 micro size, click. My VPC Cloud Genius, yes. My subnet PC.
So I guess some of you are already reviewing the videos, and some of you are doing it right now, apparently. So hang tight. Yeah, you probably will finish the videos in very, very quickly. And some of it may not be easy to digest. I'm just cautioning you, but it's okay. We will go through this. Now, I just told you this idea of a rule, what I mean by a rule, and this general structure of a rule, allow, disallow, from this point to this point, which protocol, whether you allow that or not, that's a rule. And a collection of such rules will become security group. It's a group, it's a collection of rules. Now, how does it apply in real life? Let's go see that. So in real life, I could, in my desktop computer I have here, and I decide that I want to access my desktop while I am at a Starbucks. So I am here having coffee at Starbucks, and I want to get into my desktop in my home. How do I do that? Is it possible, by the way? Is it possible? Have you seen such a thing? So there is a router, and here is a public IP address, and this desktop has a private IP address. And so I told you it is not routable. So you cannot even go there from outside, and I am outside. So now what? I have a laptop here with me, and it has the Starbucks IP address, which is a public IP. Maybe it's a private IP within the Starbucks, and there is another NAT device here. But yeah, it is outside the subnet, outside the area of my home. My home boundary is this red boundary. So how do I enable, from a security group standpoint, the core principles apply something like this. You have to set a rule aside that says that allow traffic to originate from this laptop to go to this desktop, provided the traffic flows through in a specified manner, which is going to be port number 20 through the SSH protocol. If I allow that protocol and open up that particular port in here for traffic to originate from this laptop going inside, then that constitutes one rule. So I'm saying allow my laptop to connect to my desktop using port number 22 protocol SSH. That is one rule that I just discussed. And if I put that rule in place, I am and will be able to connect to my desktop just fine. if I have such a method of putting together a rule like this, allow laptop to desktop communication through this port number, this protocol, then in that case, I should be able to get from here to my desktop, no problem. That's the kind of usage that you will see in security group scenarios. And we will discuss that. This concept of security group used to be only with Amazon, but other two big clouds have implemented similar setup. The other people call these things by different names. The idea is the same. The idea of security group, like here, is also known as network in Google Cloud. And in, I think, Azure Cloud, they call it virtual network.
Are they basically the same idea as
Exactly, exactly the same idea.
In your firewall configuration?
Yes, yes.
Okay.
Yeah, it is basically based on layer 3 routing and IP tables. So here, IP tables routing, not IP tables is a method of net filter in Unix. So you let me give you a right link for it. I think this is a better human readable link. So that's the net filter method of filtering, creating a firewall in Linux that you can read, and that is the kind of core idea behind security groups, behind any other technology that you will see. And you will see this thing, which is, hold on, in my router, which is opening up. You will see that Apple implements something. What? My password is wrong. Edit. Okay, this I'll deal with this later. But the core idea is, in my router here, if you go and see, I am allowing certain protocols. Where is that? Internet options. No, not here. This Apple router is kind of difficult to read from. Yeah. Hold on. Let me go identify that. I think this must be it. Yes. So here you can set a security group or a firewall entry in your router if you like. You can say that allow remote access from port number 22 to port number 22 in the private area for my desktop, and private address should be 22. And that way I can allow the rule that I just described to you in my write-up. I implement that rule just like this, by opening up port number 22 access through my router all the way to this machine inside here, which happens to be my, where is my desktop? Yeah, this one. I can access my desktop if I open up that port 22 like that and allow laptop to desktop traffic through this port, through that protocol. Now, Apple router is very, very limited in terms of going elaborate in defining the sources. Like here, I have no way to define it here in the router. Like I only get to define the destination, which is this IP address. I don't get to define the source because it is very limiting. So I cancel it. But in the context of cloud, you will see that it does allow you to specify further elaborate details, just like a origin, where do the traffic originate from, and a destination, where does it go to, and the port and the protocol used, and allow or disallow. All these aspects, you can see them in an example that we will show and discuss and play with in our next step, which is going to be on Wednesday. Now, I have a question for all of you. I know some of you are traveling from the East Coast to the West Coast and are currently here in our area. I would suggest that we get together, at least those of us who are in our area in the state of Washington. Why not we get together for lunch? Is that possible? Is that something that you want to do? I would like to know. I think Justin is here, if I understand. Is Justin online right now? I guess he just chatted with me that he is here. The other day we chatted. So I'm suggesting that we get together for coffee or dinner or something sometime this week while he is here. If that is open to you, let me know. We can set aside a date and go meet face to face. At least those of us who are local to our area. And I'm sorry for other people who are away from us. I will go and see you guys at some point, or you come and see us when you are here. So I'm suggesting that we meet on Thursday when we don't have a session. So at Thursday in the evening hours, that's what I'm suggesting, 27th. Will that work?
I can make that.
Okay. So let's go in Slack chat and say, 6 o'clock in the evening, we get together for Dough Zone, have some dumplings at Dough Zone Redmond. That's my suggestion. Any other suggestion is welcome. Dough Zone Redmond, 6 p.m. Thursday. That's my suggestion. If you can join, please say, yes, I can, and we will get together. And for others, I'm sorry, we cannot meet you right away, but I would like to. And I will make sure that I go and meet you when I can in your area. Or if you come here, you meet us, please. And with that, let us get together in the session again here at 26th, which is Wednesday at 4 o'clock Pacific time, 7 o'clock Eastern time. Please translate time zones accordingly. And see you guys on Wednesday, 26th. Thank you. And I will now also send out, thank you guys. I'll also send out this, stop the recording first, and then send email invitations for those of us who can make. And I'll send you the address as to where we will actually be there together.
Sounds good. Thanks.
Thank you, guys. Thank you very much. Hey, Kalaivani, I was curious about the last time you mentioned this thing, unable to access. Did you go to Bellevue College or something? Or what happened?
Yeah, I was taking a certified Scrum Master class, and after that, I was trying to catch up with this class, and they said no, Fridays they are basically close at 5, so I couldn't basically attend that. So yeah, that is kind of affecting how I can understand today's. But I was also checking the Slack chat for the recorded link. Where should I check? I couldn't find the recording of Friday.
I see.